All right. Welcome to my channel. Hello, everyone. Happy Wednesday. I hope everyone is doing well. And I am hosting this live stream for Math Help. And so if you have a problem you'd like to see me work out, you want to hang out and do some math, you can post the problem in the chat. I am talking about right now working with force vectors, and I'm going to use this problem. And so yesterday I was really walking on unsteady ground when I was working this problem, and it just makes me realize I need to practice. It's hard for me to practice, so I'm going to try to practice more so I don't look like a total dum dum up here. But um, it's funny how our brain is wired to find the mistake and always, see the problem. And so, yeah, I did a lot of things right yesterday, but I made a mistake, and it's like the one mistake really bothered me because after I realized I made it, I couldn't like really get on there and fix the mistake. So I had to just sleep on it. And of course, whenever I woke up this morning, I realized it wasn't as big of a deal as I thought. And I still want to fix the mistake, and I want to use this opportunity to try to explain how to find the standard angle if you're only given a bearing, because that's where I went wrong. I did everything else correctly. And I really, really am appreciating ChatGPT for the fact that I know enough about the math to know what question to ask to get the right answer for this problem. And so that was kind of exciting because my old textbook didn't have the solution. And in these old textbooks, they just give you the answer. They don't even have like a workout. So they don't even 20 years ago when I was going through all these classes, there you were really just, you know, left to your own vices, because there wasn't a lot of resources. But ChatGPT is awesome for that, and it's not a plugin or anything. I just really appreciated it because I was quickly able to identify exactly what I did wrong, and I figured out, it was a learning. Again, I probably knew this at one point in time, but trying to revisit the material. Anyway, so my mistake here was in calculating these angles. So what I want to do is I want to box the values that I want to keep, which is really just these R values. I want to keep those two, and then I want to keep the angle theta, or the actual angle. So actually, all I really need is the magnitude and the angle. So the angle theta was right here, 71.98. It was very close. I was so close. And it's amazing how close I was given the fact that I messed up the angles. So let's go ahead and just put these off in the corner, and so I can erase everything and show you. So we got 71.98 for the resultant theta. And we have for the magnitude of the resultant vector is 190 point 190.03 maybe. We'll go out 2 decimals on those, and then just so I can show, we can contrast and see how close I was. And I am not going to call these angles. So when I was working this out, because I realized I was trying to discipline myself to practice more, I realized that, oh yeah, it's not even called theta. When it's dropped down in a bearing, it's I think it's referred to as phi, and they're all Greek letters, but phi is for bearing. It was for spherical coordinates, use phi, and that's a little bit over. I'm gonna have to remember. Hold on. It was 71.98 degrees. And this was all right, the force vector, the magnitude of B. So that's R sub B is that was what was it, 190.03. That was close. All right. So not a big deal. I just want to be able to measure, like show you the difference. All right. So let's just get into it. And instead of this, I'm going to go ahead and erase the title too, because I'm going to be finding the standard angle. And I don't have to go through the whole method. We'll just recalculate everything after we've used the correct angle, and I've kind of explained. So how to find the standard angle theta. Okay, so if you're given a bearing, okay, if given a bearing B. All right, and switch the bearing. So we'll go ahead and get our Cartesian coordinate system out. It's really our compass. And east is the positive direction, and west is the negative. And you got north, positive y, and south, negative y. And these bearings that were given, and I was really impressed that I calculated this bearing, and I remember the bearing at least. But north, 23 degrees, 10 degrees west. So the two, let me just pull up the problem again. And since I don't have to, I worked it yesterday, I don't have to really spend a lot of time explaining. I can just put the values in here. So this one was the one that I used. It was 47 pounds acting on north, 23 degrees, 10 minutes west, and 163 pounds acting south, 84 degrees, 30 minutes west. That was the original problem. And so I drew the bearing for the first one, 23 degrees. Here is, let's see, 45 would be halfway, and then 23 was like, I figured it was like halfway between 45. So I figured 45 and then cut 45 again. It should be like maybe right in there. And instead of theta, I'm going to call this this angle, I'm going to call it phi sub 1. And this one is, we'll put it in decimals. And we'll say phi sub 1, 23 degrees and 10 minutes. Is 23.16 repeating. And phi sub 2 was 84.5 because 30 minutes is half of a degree. So it's 60, there's 60 minutes in 1 degree. And there's 3,600 seconds in 1 degree. And so that's how you make those conversions. And you go back from decimal to degree, minutes and seconds. So phi sub 2 is going to be 84.5 in its degrees. And my markers, after a couple weeks, these markers just wear out. It is what it is, unfortunately. Maybe I'll get some fancy technology one of these days. All right, so phi sub 2 is south, 84 30-minute west. So this is going to be the third quadrant somewhere. And then, so 84 degrees out of the south, that's a negative measure up here. Because since there's only 90 degrees in here, there's only about 5.5 degrees left in this angle. So it's really close. So after thinking about this a little bit more, I decided to sketch it slightly different. And here is your phi. Sorry, it's not correct. It's here. And this is phi sub 2. 84 degrees. And that's kind of important because when you're calculating the standard angle measure is starting at, in the first quadrant at 0 degrees. That's kind of important. So for a standard angle, and you're going in the counterclockwise motion, and that's how you're finding that standard angle. So if I have this piece of it and I have to add this quadrant, then what I'm in essence doing is I'm adding 90 degrees to figure out if I'm going here and I want to find out what's going all the way around here. I'm missing this standard. So the standard angle measure starts here. So however, to get here, now I'm going to add 90 degrees to this phi sub 1 so that that'll tell me the standard angle, okay? So standard angle. And this is where I made the mistake. It got me really close, but it didn't get me exact. I knew something was up. I just couldn't let it go. So after the live stream last night, I went ahead and researched a little bit and figured out my mistake. And all right, so we've got phi sub 1 plus 90. And phi sub almost 23.16. And I want to kind of sketch this out here. We'll sketch another one. Look. So we've got this thing going. And the standard angle is all the way here. Okay. So that's going to be 23 plus 90. 23.16 repeating. Plus 90 degrees is 113.166 repeating. Okay, so I'm getting 113.16 repeating. And that is the standard angle. And it's important because whenever you're figuring out where this resultant is, you're going to end up in the wrong quadrant. And that's why my resultant, my angle, and when I calculated the reference angle of the resultant, I recalculated it and it put me in some other quadrant, first quadrant or something. But we'll recalculate all that too. So it's good little learning experience. So we've got that one, and then standard angle for phi sub 2. Let's think about this one now. We've got, put it down here. Oh, these markers. I'm gonna try and make them work for this one, and then I'll dig some more out tomorrow. If not, we'll have to interrupt. I think this one's good. All right, so we've got phi sub 2 that we're going to think about now. And we're down here. And if I want to find all the way around here, this is a negative angle. So this one's actually going to be a little bit harder to calculate, because what I've got to do is I've got to start here, draw the negative angle, and then find the positive. So here's how this one's going to work. Let's go ahead and draw the picture. So I know that this, we'll put it here. I know that this vector, okay, that's right here. And it's probably not drawn to scale. But this is a rough sketch. And what they're giving us is this angle here. And what I need to find is this angle. So it's kind of like a puzzle where I need to find this portion of it, this whole thing, and then add to 360 to find this angle. So I hope that makes sense. So we're going to say phi sub 2 is this angle right here is 84.5. So to calculate the standard angle of phi sub 2 here, standard angle phi sub 2. This is the standard angle of phi sub 1. And again, this is me trying to learn how to present more advanced topics. I studied these in college. My teaching experience was just the basic math in secondary. And then I did get to teach some of the pre-calc 1 and 2 for community college. And that was like the hardest thing I've ever taught, probably. But I mean, level of difficulty for math anyway. But my brain begs to study this math though. So that's where we're at. And I honestly say that I'm not an expert. I'm just somebody hanging out doing the math. Right. So since I have this chunk here is 84.5 and I want to know all of this angle, I'm going to do a similar process here, only it's negative. So you have to remember negative angles. So this is a negative. There's no such thing as -0, but I guess in angles they're it's a 0 line here. And this line represents 0 degrees and it represents 360. And a lot of other degrees too. So it's also -360. It's a lot of this line right here. It's a lot of lines, a lot of degrees. So the way the negative angles work is you have a positive direction here and you have a negative direction here, and it's very similar to where, you know, on your quadrant system, your coordinate system, you have a positive direction and a negative direction. Well, the way the negative angles work is kind of similar, only it's split up here. It starts here rather than in the origin. So this is your 0 line. And so this would be -90, -180, -270, and then -360. So this right here is -90, right here. And then this one is considered a negative angle since it's going this direction out of the south. So this is technically -84.5. So when you calculate the standard angle phi, it's going to be phi sub 2 minus 90, or actually it's plus a -90 is what it is. but when you plus a negative, the negative is going to win. So unfortunate reality. But Q sub 2 is negative, so it's negative 84.5 plus negative 90. And I'm getting negative 174.5. So negative 174.5. And that's important because I now know that this entire negative angle to this point is negative 174.5. Now, if I want to find out this angle, all I have to do is add 360 to it. Because I want to know the whole distance minus this little piece. And it's going to put me back here. So all I have to do is say 360 degrees minus 174.5. And that will tell me my positive angle here, my standard angle, theta. Okay. All right, so let's do that. 174.5 plus 360. And I'm getting 185.5. So 185.5. And this is in degrees. All right, so this is our angle theta. So we found theta finally. So we've got theta sub 1 is 113.16, and we've got theta sub 2 is 185.5. And that's important because whenever you're breaking up these components, so you've got the force sub x sub 1, and then remember that force was, we calculated that as the magnitude. So force equals the magnitude of V times angle theta. And from that, we've got the components. F of x sub 1 is going to be 47 cosine. And instead of that angle, whatever I had yesterday, I'm going to plug in this one, 113.16 repeating. And then f of x sub 2 is going to be this next one, 163 times the cosine of 185.5. Okay, now we've got f of y now. So f of y sub 1. I just realized you can't see what I'm writing. So we've got f of y sub 1 is going to be 47 times the sine of sorry, I just had a thought. Okay, so 47 sine of, where's my theta? 113.16. And I just thought that I didn't show you how to find the reference angle from the standard angle. In this case, it's not really necessary because if you don't use the reference angle, it'll tell you what quadrant it's in when you punch it in, when you type it in the calculator, depending on the results of tangent. And so in this type of problem, you don't really need the reference angle, but it is very handy to calculate, and it's very useful to know how to do that. So a lot of the application problems will require you to calculate that reference angle. And we've done all the work, so we might as well It's not relevant to this problem, but we'll do it. So f sub y sub 2, I'm going to keep track of these different values, subscripts on subscripts here. So we've got 163 times the sine of here, this is theta sub 2, 185.5. 185.5. And remember that sine function is expecting a degree measure into its domain, and it's going to return to you a side length, a ratio. So it's a ratio in the triangle is what it's giving you. So we're multiplying that times the magnitude to come up with this force, this vector. So let's go ahead and calculate the decimals of these real quick, and then the process of finding the resultant, plug that one in here. We'll put it here, resultant. Force vector. So what you're doing is you're adding your components separately. So you have R sub X, and you're going to find out the decimals of that and plug it in, and you'll have R sub Y. And then the resultant force, R sub F, is, well, it's the magnitude. Hold on. So let's see, we got those, and then we'll plug in the magnitude of the so it's the magnitude of the resultant force, and you use that you find that using Pythagorean. So it is the square root of x squared plus y squared. So we'll go ahead and wait to plug that in. All right, let's do it. We have to wait a second. We have to add okay, so the resultant of f is going to equal x sub 1. It's f of x sub 1 plus f of x sub 2. That's r of x. Sorry, I didn't mean to erase that. I'll try to figure out what I'm doing here. All right, and so then this one is f of y sub 1 plus f of y sub 2. So we're going to figure these out, add them together, and then we're going to square them and take the square root. All right, so that shouldn't take very long. All right, we've got 47. Times the cosine of 113.16, and that's giving me a negative 18. I didn't have enough room here. This one is hold on, f up. We'll say this. Where do I put this? Why am I getting hung up on this detail? Okay, 18.5 negative. Circle it. And then 163 times the cosine of 185. I'm getting negative 162. Negative 162.4 for that one. And so then when you add them together, and Okay. I'm getting negative 180.9. I'll circle that. I'm just trying to round out to the tenths because I ran out of room. And I'm going to run into the same problem here, so I'm trying to scoot it over. All right, so we're going to go ahead and do the sine. But 47 cosine, so 47 sine of 113, and that's 43.2. 43.2. If it's too clustered, I won't be able to read it. 163, and no one else will probably be able to read it either. One sine of 185.5, and I'm getting negative 15.62. Negative 15.6. And so adding those together, I got 27.6. So when you plug in to your square root and square this, because you're using Pythagorean and you're essentially solving for your hypotenuse, and when you square, so you're going to put in 180.9, it's negative, but when you square it, you're going to get a positive. So you want to, when you plug this in your calculator, you want to make sure that you use parentheses, because your calculator is not going to, you'll get a negative, and that's because your calculator thinks you're multiplying it times 1. So this is 27.6 20 squared. And so I just plug this in all at once. I just do the square root, put an extra parentheses, separate them by parentheses, and I just put it on exactly like it shows. So it's negative 180.9 squared plus 27.6 20 squared. And that's giving me 182.99. So I'm just going to round that up and say it's approximately 182. That is the magnitude of the resultant. And so I think I would assume that represents pounds because these magnitudes are in pounds. So I'll say the magnitude of this resultant is 182 pounds. And then the direction, the angle, and then also I looked and put it back in a bearing. So we'll go back and put it in a bearing after we're done. One of the beauties of making a mistake was that I automatically knew what I was going to talk about tonight, and I didn't have to think about it. It's like, I have to fix this, and own up. Can't be perfect. All right, so now we have to talk about, since we calculated our magnitude of our resultant, this is wordy, so I'm going to go ahead and box this with it because that basically is what we were trying to achieve, and we got close yesterday. See how close I was? 182 and 190. Very close. I was surprised. All right. So what we got to do first is we're going to calculate the angle of theta, the angle of the resultant. So so we'll just call it the angle of the resultant force. And again, we're going to use tangent for that because of the the tangent is the side length, so you don't have to worry about the hypotenuse. So if nothing is known about the hypotenuse and it's just the side lengths given, you can use the tangent. Tangent, by definition, is opposite over adjacent. So opposite is a sine and adjacent is the cosine. So we have tangent to be, sine over cosine. So that's going to be 27.6 divided by negative 180.9. And this is going to give me a fraction that's less than 1. And remember, tangent will take, has a restriction in its domain, but it has only intervals. It only has the restriction of pi over 2 and intervals of pi over 2. But however, we have to use the inverse tangent to solve this. So the inverse tangent function actually will take any number into its domain, but it only returns values between positive 90 and negative 90 degrees. So we'll have to, so positive 90's here, negative 90's here, so we're just going back and forth between here. So tangent, inverse tangent only exists here. If that makes sense. So we're going to go ahead and put this in here now, and because what it's expecting into its domain is the ratio, and then it will return to you the angle. So what this is it's a ratio of side lengths, because it's the vertical and horizontal component of the force vector. So we've got this is going to give us theta back. And so we'll plug this in our calculator. Before machines, they had tables. And we have machines now, so I'll just go ahead and use it. So I've got inverse tan, 27.6 divided by negative 180.9. And I'm getting negative 8. So I've got negative 8.6, 747, ... So we're just going to round that anyway to the 10th place to save room. So that's negative 8.7. And then what you have to do is when you use the inverse, you have to remember that it's only going to give you a value between negative 90 and positive 90. So that's only giving you the reference angle. So it's only existing here and here, positive 90, negative 90. Then you have to remember where is, so it's a negative 8.7. So this is goes back to a little bit of understanding of the quadrants. So you've got quadrant 1, and you have both x and y are positive. And then you have quadrant 2, and you've got x negative and y positive. And then you've got quadrant 3, they're both negative. And you've got quadrant 4, and quadrant 4, x is positive, y is negative. So when you calculate tangent as sine over cosine, you've got positive over negative, which is negative. And quadrant 2, you've got negative divided by negative, which is a positive. In quadrant 1, they're both positive, and then in quadrant 4, you've also got a situation. So it's positive, it's negative here, and then tangent is also going to be negative here. So it's only negative in quadrant So that'll be 4 and quadrant 2. And let's see, how do I know that it is in quadrant 2? So this is how I know. Wait a second. So we've got sine positive and we've got cosine negative. So I'm looking for the quadrant where the tangent is negative and we have the situation where it's positive over negative. So we must be in quadrant 2. And the reference angle is measured from the x-axis. So in quadrant 2, we're looking at for a reference angle for our resultant vector in positive 2 at approximately negative 8.7. Right there. This is where you get the resultant theta flips. So this is theta of the resultant. Okay, right there. And this theta right here, that is a reference angle. So if I want to find the standard angle of that resultant, I have to, again, all the way here, I'm going to go ahead and add 180 because all 180 is going to get me here minus this little piece. So if I say, if I want to know where this angle is, all I have to do is add this angle of the resultant to 180. So I'll have of the R, that is going to be 180 minus 8.7. So that'll tell me the standard angle of the resultant, but that's not the angle. Hang on. Yeah, so we'll go ahead and do that one. I don't know if that is what I need. Hang on, let me think about it. 80 minus 8.7 is 171.3. Okay. And we're in the second quadrant at, so this angle here, all the way here, from here, is 171.3. Now, I did good. Okay, I did good. Now, if I want to return this back to a bearing, okay, because it's standard practice to, what you're doing is when you receive the information in a word problem, it's important to keep all of your calculations. When you can work the problem however you want, but when you return your answer and you present your answer, it should be in the same units. It should be in the same, if it's a decimal as versus the exact, you want it in the same form that it was given in the context of the problem. So I have the standard angle calculated, but in the context of the problem, the answer was given to me in a bearing. So what I need to do is I need to calculate the phi of the resultant, which would only be from here to here, correct? Or sorry, yeah, I'm a little ahead of myself. Right here up into theta sub r. So what I'm going to do is now all I have to do to find that is just to subtract that standard angle back from 90. So I'm going to take 171.3, subtract it from 90, and then that's going to give me my my bearing for my answer. Okay, and then I'll be able to put the answer back in the form that was given. So let's just do that. Let's say 171.3 minus 90. Okay, and so that's giving me a bearing of 81.3 in quadrant 2. So I'll put in here B, and I really feel like this part is disorganized, but I hope it's not too bad. All right. So you've got, just trying to find a marker to write this. So we've got phi of the resultant now. Let's write this down so I don't figure out a good clean place to put it. Is 81.3. 81.3. Now we're not finished yet because notice it's giving us in degrees minutes. So this form. So our phi of our resultant is going to be 81.3, but let's go ahead and change it back to degrees, minutes, and seconds. And I'm getting 81 degrees, 18 minutes, 0 seconds. 81 degrees, 18 minutes, 0 seconds. All right, so we're almost finished. What we have to do now is just go ahead and state the problem. In fact, we're going to go ahead and put our resultant. And where do we want to list the answer? I ran out of room. So the resultant here that we calculated was 71.98. 81, that's very close. And the magnitude was 190. It was actually 182, very close. So the only reason why I saved those values from yesterday was I wanted to show everyone like how close I got, but I didn't want to let it slide. If you make a mistake, it's best to leave no stone unturned in your learning and go ahead and handle the mistake. So we'll go ahead and put the new answer up here that it's the correct one. And we're going to go ahead and put it in the bearing form, back return in the form, just to be thorough. And we're going to say 182, the resultant, resultant force, okay, is 182 pounds. And then you're going to say, since it's in quadrant 2, you'll say north 81 degrees, 18 minutes west. And there's the answer. There's the correct answer from yesterday. Yay, I did it. And yeah, so feel a little redeemed, and I didn't realize that it was going to take me that long. So I apologize for that. But again, this is just a learning process and trying to learn how to speak clearly, concisely, not be so camera shy. I'm working on that. I am scared of the camera, and I know it's not a rational fear, but maybe it is. So anyway, yes, it's time to close. I'm going to go ahead and end. And I just want to say thank you so much for watching my videos and letting me know how I'm doing. If I'm not doing well, I need to know. And if I'm doing well, I need to know that too. That's just so I can improve. I'm not trying to be perfect. I just want to be effective. So anyway, I better say goodbye for now. And I will see you again tomorrow, same time, same place, and we'll pick it back up. All right, bye.